Testing 1 2 3, testing 1 2 3. Alright, welcome back to the video, another video, and I hope you're having a good day. So where were we last time? So let's just go to the, this is it. Before that, I just want to do one thing. I just want to test my audio. Hello, test. Alright. Okay, so here it is. So this is this has become Python 3.130 B1 documentation, and also just give me a minute, please, for that. Alright, so yeah, we were at the, just a minute. Okay, just one more minute. Alright, so I'm just testing the audio, but there seems to be a slight bit of testing, hello, testing, hello. If I keep it at minus 2.1 dB, is it better? Alright, testing the quality of the sound, hello, testing 1 2 3, testing mic. Alright, so let us start. So this is what's new in Python 3.13, as this is 0B1, and also, last time I actually, where did we leave it? Have we read it till here? Also, there's a lot of new stuff that's been introduced. And, yeah, a lot of new stuff. Free threaded Python. Garbage collection. Also, alright. Is this all of this new? Wow, there's a lot of new stuff. But last time we left it till here, Python frozen modules. Added a new environment variable, Python frozen modules. So we're going to continue from here, frozen modules. Add support for the perf profile working without frame pointers through the new environment variable, Python underscore PERJIT support and command line option dash XPERF underscore JIT, contributed by Pablo Galindo and GH 118518. Alright, so we're going to check this out. Also, let's not forget, did I forget perplexity? Oh, damn. I forgot about completely about perplexity. Let's not forget perplexity. It's just awesome, and it's amazing. It's incredible. Perplexity is awesome. It's amazing. All right. Okay. So where were we? So we've already done the Python frozen modules. Okay, so add support. So we're before that, let me just copy and paste some stuff. Right. Could you explain this website? Okay. The search results indicate that Python 3.13 will add support for the Linux perf profiler to work without requiring frame pointers. Specifically, Python 3.13 will introduce a new environment variable, Python underscore perf underscore JIT underscore support. That is it, right? Yeah, Python perf JIT support without frame pointers. So it's not going to need the frame pointers through the new environment variable, through this. So if this new environment variable is going to be used, so then the frame pointers are not going to be needed. So the perf profiler can work without requiring frame pointers through this variable, right? Through the new environment variable, Python perf JIT support. Alright, so Python 3.13 will introduce a new environment variable, this, and a new command line option. Dash X. Is this dash? This is dash, right? Let me just focus on this. So there is a difference. So this is the underscore, and this is the dash. This is it, right? Let me know down in the comments. This is the dash, I think, and I think this is the underscore. That's what I think. Alright, okay. That allows the PER profiler to work even when the Python interpreter is not compiled with frame pointer support. Command line option. That allows perf profiler to work. This is an important improvement, as the previous requirement for frame pointers limited the usefulness of the PERF profiler integration into Python 3.12. The new options will allow PERF to profile Python code more effectively, even on systems where frame pointers are not available or have been optimized out. This change was contributed by Pablo. Yeah. Yes, it was done by Pablo, the primary contributor behind the initial PERF profile support added in Python 3.12. In summary, the new Python perf underscore JIT underscore support environment variable and dash capital X perf underscore JIT command line option in Python 3.13 will make the PERF profiler integration more robust and usable by removing the previous requirement for frame pointers. Alright, cool. How do we use this new thing in our code or as a code? I'm learning to code. Python. Alright, Perplexity. How do we use this? What is this? To utilize the new Python underscore perf JIT support environment variable and the dash x perf underscore JIT. Let me know down in the comments what do you think about this. Command line option in Python 3.13 for profiling your code. You can follow these steps. Profiling my code? But it doesn't say anything about profiling. Add support for the... Oh, yeah, it does. Perf profiler. Okay. Add support for the PER profiler. Yes, it does. There is a word known as profiler. Working without frame pointers. Okay. Using Python PERJT support. You set the Python PERJT support environment variable in your system. This can be done in various ways depending on your operating system. So this is Linux and this is Unix. You can set the environment variable in the terminal for running your Python script. Export Python underscore perf underscore JIT support. Alright, so we're gonna just this is for Linux and Unix. Alright, okay, export Python. So first we're gonna do the Python for Linux slash Unix. What is it? Python underscore perf underscore it's JIT and support is equal to 1. Python your script.py. It's all capital. Python. In Windows, you can set environment variable through the control panel or using the set command and command prompt. So for Linux or Unix, this is the way to set the environment variable in the terminal before running your script. Okay. But for Windows, you can do it through the control panel or using the set command and the command prompt. So the first line, I think, is the same, which is, no, it's not. It's set over here. It's the word is over here is set. So let's change this for Windows, which is set Python PERFJT support is equal to 1. Everything is capital. And the second line is the same, Python your script.py. Using -xperf underscore JIT command line option, when running your Python script from the command line, include the -xperf underscore JIT option. Command line, Python. Alright, so this is how if we try to run some Python script from the command line, then we have to include the -xperf JIT option. So how do we do that? It's over here. So it's Python -x. Alright, so PERF underscore JIT and then yours underscore script.py. Alright, by setting the environment variable or using the command line option, as described above, you enable the PERF profiler to work without frame pointers, allowing for more effective profiling of your Python code in Python 3.13. This can help you analyze and optimize the performance of your program. Can you provide me a simple program for this that I can run quickly in Windows? So here's a simple Python program you can use to test the Python PERFJIT support. Environment variable and the -xperf JIT command line option Python 3.13 Windows. Alright, so we're going to test it out. I hope nothing it doesn't mess up my system. Hopefully, I don't know what's going to happen. Alright, so Fibonacci series. Okay, and then N. If N less than or equal to 1, you have a colon. Return N, okay. Else return Fibonacci N minus 1. Alright, so here N is equal to 35. And then print we have these quotation marks, the okay, the nth Fibonacci. Do we pronounce it like Fibonacci or what is it? Fibonacci or Fibonacci number? I don't know how to pronounce this. Is look, have you noticed that we're using these brackets? These are called curly brackets, right? And these are called small brackets. Tell me no and let me know down in the comments. So these are the curly brackets. We can just see the names of the brackets. Curly brackets, also known as braces. Okay, it's curly brackets. So these are being used a lot in the code. And then we have these small brackets. Okay, so there is something wrong with this. It starts from the 5 Fibonacci. Did I forget something? Yes, I did. Here it is. Alright. So that is it. Alright, so if n is less than or equal to 1, it's going to return n. Otherwise, it's going to return Fibonacci n minus 1 plus Fibonacci n minus 2. And then we set n is equal to 35. And then print the nth Fibonacci number is... Save this code in a file, for example, Fibonacci.py. Alright, saved. Command prompt. Alright. Shortcut for running command prompt on Windows 11. Windows key and R. Okay. Command prompt. What? Alright, here it is. This is CMD. So what we're supposed to do next, we have to run the program of the Python perf JIT support environment variable. But before that, after doing all this, how do we unset this stuff? Alright, so I don't actually know what's going to happen. Well, we have to test it, right? So anyways, let's do it. Python perf JIT support is equal to 1. Alright, that's done. And then we're going to run Python Fibonacci. Now actually, the name of my file is... This is the name of my file. So we're going to paste it here. .py. No such file or directory. Wait a minute. Have to cd to a location in CMD. Or we need cd to this. Alright, so here we go. What? No such file directory. It's weird. Okay. I don't know what to do. Well, might as well just run it here. Yeah, look, it's running it over here. Add 2, 3, 4, 5. And then 0, and minus 1. Alright, let me just run it again. So 10, 2, 3. Just one at a time? Let me just run it again. 5, 6. This is sort of, so we've done this. So I think we should move on to the next one. Alright. To run the program with the xproof data command line option. Open the command prompt. It wasn't just the command prompt? Yes, this was the command prompt as well. Okay, so now we're going to run it with this script. Okay. Press the wrong key. Alright, so let's just do it here. Python. So this is the command X curve DIT Fibonacci. No. The name of my file is. This is the name of my file. No such file or directory. This is weird. What am I doing wrong? I don't know. This is I don't know how to do this, to be very honest. I mean, I'm writing this command, but it's not working for me. Maybe I should just paste the error. When I run python-x perf_JIT. Correct directory. Alright, correct directory. Python 3.13. I'm using Python 3.13.085. 64-bit. How about if we try to CD to download? Alright. Python-x perf JIT dot. Well, I pressed entered, and that's it. So yeah, so this is the working of that. So I think we should move on to the next one, because I think I need more knowledge, more skills to work on this. So I gotta enhance my skills somehow, because I'm not able to do this. Alright, so this was the xperf_JIT and Python perf_JIT support. The new Python history environment variable can be used to change the location of a .python history file. Contributed by Levi Saba, Zachary Spitz, and Hugo van Kemenade in GH73965. Alright. Copy the link of the website, and then we're gonna paste this. and ask perplexity about this. Now explain this. The new Python history environment variable introduced in Python 3.13 allows users to customize the location of the .python_history file. Change the location of a .python_history file. This enhancement was contributed by these people, part of the development issue. By setting the Python history environment variable, users can specify a different path for the .python_history file, providing flexibility in managing Python's command history. This feature enables users to organize their Python history file in a location of their choice. Environment variable. How do I use it in code? To use a Python history environment variable in your Python code, you can follow these steps. Set the Python_history environment variable to specify the desired location and name for the .python_history file. Outside of your Python using operating system environment variable management tools. On Windows, you can set the environment variables through the control panel or using the set command in the command prompt. So this is set Python_history custom history.txt. So how do we do it on Windows? We first have to set the Python history environment variable to specify the desired location and name for the .python_history file. To specify the desired location and name for the .python_history file. Outside of your Python code. So we have to do this outside our Python code. Right, so if I do this, how's it gonna affect the system? Read the .python_history file if it doesn't read history file. Keep your Python command history separate from the default location. Before starting Python or running a script, let's changes take effect. Alright. We're just gonna write it down for practice. So it's set, for Windows, it is set Python_history is equal to C. Alright, and then this \path /2 \custom, and then we have backslash history. No backslash, it's history, it's custom history, path to custom history.txt. This is the command for the Windows, and on Unix systems like Linux or Mac operating system, you set the environment variable in the terminal. And so for Linux and Mac OS, the word is different. It's not set, it's export. The rest is the same. Export Python_history is equal to C. No, there's no C over here as well. There's no C here. And there's a / path /2. I put a backslash. My bad. Path to custom. Alright, so path to custom _history.txt. History.txt. Okay. Start your Python interactive session or run your Python script. Python will now use the specified location for .python_history file. So, what stuff can I see in this file when I do this? Record of the commands you have executed in your Python interactive sessions. Commands entered in the Python interactive shell, for example. Imports of modules and packages. Assignments and variable manipulations, for example. function calls, and expressions, for example. And you can open up a text editor to view the recorded commands. However, it's important to note that the file is not meant to be edited manually, as it may cause issues with command history functionality. Setting the Python history environment variable, you can conveniently access and review your Python command history. That's the location, making it easier to reference or use previous commands. I think I want to try this. Set command and command prompt. Command prompt. Alright, so we're going to do this. Alright, so set. Before that, can we undo this after doing it? To normal. Alright, so this is it. Alright, but before that, I just want to submit. Alright, okay, so it's not telling me how to undo this. You know, I don't want to mess up my system. Yeah. Because I really have no idea what's going to happen. I know it's for the Python history, like whatever commands, what I understand from this is that whatever commands I'm using in the Python shell, right? Where is it? Yeah, this is the Python interactive shell. So when I open it and do stuff in it, it's going to record the history in the .python history. That's what I understand from this. But, okay, let's try again. So, how do I undo this? Unset Python history. Check by echoing the variable in command or terminal. To ensure the changes take effect. Python history. Alright, this looks interesting. Let me just check the volume. 100. Alright, testing. Alright, so I'm just going to create the file over here. New text file. And I'm going to name it customhistory.txt. Copy as path. And then we're going to open the command prompt. Set python underscore history is equal to what's this? How come there are two txt's over here? That's weird. Alright, so this is it. It's done. It has been done. So now that means if I open the Python interactive shell, what is the second step? So give me a minute. So we've done the first step, set Python history to the path. Alright, already done. Start your Python interactive session. Alright, so now I just gotta open the interactive shell. Before that, give me a minute, please. Alright, so I'm going to open the Python interactive shell. Here it is. Alright, it's been opened. As you can see, this is a Python interactive shell. So what does Perplexity say? So for example, if we print hello world, so the Python history file is going to include the commands entered. So I'm going to write print command. Print hello world. Alright, so if we open the file, where is it? Well, it's supposed to have the history. That is weird. It doesn't seem to have the history. Could you give me a minute, please? This is weird. I mean, it's supposed to have the stuff, right? The stuff that Perplexity was talking about. Multi-line commands. Import math.py. Alright, so I want to tell you that it didn't work for me. You can see that the custom history is empty for me. I don't know why. I don't know. Already executed command, as you can see over here. Set Python history is equal to history.txt. What am I doing wrong? So anyways, I don't know. I just don't know what to say. So, okay, unset Python history. So now we're going to unset Python history. We can do it by set Python history is equal to empty. Python history is equal to this. And then we're going to echo so how do we check that it has been unset? Echo Python history. Alright. Echo and then percentage Python history. This is it, right? For Windows. So I tried the echo Python history and the CMD on Windows, and it gave me the output Python history. So what does this mean? Has it been removed? Has not been set or has been the output Python history indicates that the Python history environment variable has not been set or has been removed. When you type echo Python history in the Windows command prompt, it simply prints a literal text Python history because the environment variable is not defined. This means that the Python history environment variable has not been set previously. If it was set, it would have printed the value assigned to it. Number 2, the Python history environment variable has been removed or unset after it was previously set. Unsetting an environment variable leaves it in an undefined state, causing it to print the literal variable name when echoed. To confirm the Python environment variable has been removed, you can check the following. Open the system properties, right-click on this PC and select properties and go to the advanced tab. Click on environment variables and look for the Python history variable in the user variable system variables section. If the variable is not present, it has been removed. So yeah, so we did succeed at one of the steps. Based on this information, based on Perplexity's answer, it says that if we're getting the literal, this answer, Python history, so that means that the environment variable has been unset. So this is the output we're getting, right? Python history. So it has been unset. But what I don't understand is that why wasn't it working? I mean, why doesn't the custom history.txt file contain something, you know? It's not containing anything. Anyway, so let's do the next one, right? This is pretty interesting. Python is quite interesting, and it's cool, right? It's good. It's good to learn. So now we finished learned about the new Python history environment variable and how we can use it to change the location of a Python history file. Before we move on to the next one, I just want to do something. Testing. All right. Can you see this? All right, it's back. Okay, so the next one is add Python finalization error exception. Python finalization error exception. This exception derived from runtime error is raised when an operation is blocked during the Python finalization. All right, Perplexity, help us out here. Help us out. So yeah, okay, with the help of Perplexity, we're going to learn Python. Next, this is next, explain this. So let's try to give it a read and try to understand it ourselves for once. Add Python finalization error exception. This exception derived from runtime errors. So what I understand from this, that this exception has been derived from the runtime error. All right? And this exception is raised when an operation is blocked during the Python finalization. Okay, so it's this exception known as the Python finalization error is raised when an operation is blocked during the Python finalization. This is what I understand from it. Python 3.13 introduces a new exception called Python finalization error that is derived from the runtime error exception. This new exception is raised when an operation is blocked during the Python finalization error. The Python finalization process occurs when the Python interpreter is shutting down. During this process, various cleanup tasks are performed, such as calling __del __ methods, running ATEXIT callbacks, and closing open files. If an operation is blocked during this finalization stage, for example, if a __del __ method takes too long to execute, or if a file cannot be closed, the Python finalization error exception will be raised. This new exception provides more specific information about the cause of the finalization failure, allowing developers to better understand and debug issues related to the Python interpreter shutdown process. Very nice. So it helps developers to understand and debug issues related to the Python interpreter shutdown process. The introduction of Python finalization error helps improve the robustness and reliability of Python applications by providing more detailed error reporting during the critical finalization stage. Wow, so that is very cool, very cool. Is there any way to use this in a code so that I can understand its usage better? Or not? I mean, it's an exception, right? I don't know if it can be used in a code. To simulate and understand the usage of the Python finalization error exception. So it is an exception, right? This is an exception. How is it possible to use an exception directly in the code? Let me know down in the comments. Let me know in the comments. Is it possible? Or like, do we have to create some sort of situation that is going to lead to this exception? So first, what is this? Import ATEXIT. Alright, so there's a class known as custom resource. And then this, simulate a long-running operation during finalization, import time. Alright, print. In this code snippet, we define a custom resource class. Alright, so this is a class, custom resource class. I see it. With a __ del __ method that, yeah, I see it. It's over here. It simulates a long-running operation, 5-second sleep during finalization. Yes, it does. During finalization, it's going to run into a 5-second sleep. We register a cleanup function to run at exit using ATEXIT.register. Yeah, I see it. To run, this is going to run at exit. An instance of custom resources created. Yeah, okay. An instance of custom resources created. When the script exits, Python will attempt to finalize and clean up resources, the long-running operation in custom resource.del. Custom resource, yeah, I see this. And then we have the __ del. Yes, I see it. We'll block finalization, this long-running operation. It's in custom resource. Alright, I get it now. So at the end, they created an instance of custom resource. This is a custom resource. This is a class. So basically, what I understand from that is they created an instance of the class and then stored it as that resource. So what's going to happen is that during finalization, this custom resource.__ del, this is going to like block finalization. Why? Because there's a 5-second sleep to it, right? This is going to trigger the Python finalization error. By running this code and observing the behavior, you can see how the Python finalization error exception is raised when an operation blocks the Python finalization process. This hands-on approach can help you understand the usage and implications of this new exception in Python 3.13. So I'm going to try this. Import ATEXIT. Doesn't this read at exit? AT@EXIT. I'm reading it ATEXIT. Is it read as at exit? Wow. Don't tell me. Don't tell me. I didn't think this would be read as at exit. Is my screen visible? Yes, it is. Alright, so here we go. ATE, import, at exit. Alright, so import, add exit, class. So now we're going to create a class. Keep the code neat and clean. Custom resource. Custom resource. No, it's a class, right? Oh, it's a colon. This is a colon, right? What do we call this? A semicolon versus colon. Yes, a colon, there's 2 dots, and a semicolon, 1 dot and 1 comma. This is a colon, 2 dots. Alright. Custom resource. Alright, import time. Time.sleep. After importing time, we're going to use time.sleep 5. Cleanup. Alright, print cleanup processes. Is this, am I using a single, I'm using quotation marks, but these are double. I forgot. I use these single quotation marks. Print. Cleaning and process resources. So here, the code is going to clean up the resources. Oh yeah, it's giving me an error because I forgot the colon. Alright, good to go, good to go. And then add exit dot. It's register. Yeah, register cleanup. And then now we're going to create an instance of the custom resource class. So we're going to store it in this variable. Custom resource. Did I forget these? Alright, so what's going to happen if we run this code? Okay, I've saved it. What happened? Did it run? What is this? Why is it not running? Delete. Run Python file. Did I miss something? Don't tell me. I don't know. What am I missing? Let me just paste all this in case I've missed something. I did miss something. What was it? Let me just see. It's running now. What was the mistake that I was doing? This is it. You see, it's not working now. But if I do this, is it an indentation error? It looks like it might be an indentation, you know? Like there's, I've seen a lot that if you give the wrong spacing sometimes, you know, there's some sort of these small problems. It might not run correctly. I don't know, that's what I think. Let me know about it, and let me know about it. If I run this, it's gonna run now. So yeah, it's giving me some sort of import error. It says cleaning of resources, right? So the code runs still here, cleaning of resources. And then after cleaning a resource, it gives exception ignored in function custom resource dot underscore underscore del at 0x0000002220C8A 3FB60. What language is that? Is that let me see. So there's the machine language, and then there's the assembly language. So this could be assembly. Wait, like, am I wrong or am I right? So machine language is zeros and ones, I think, and assembly is zeros, ones, and these letters. I think that's, I don't remember correctly. So this is the it's either some language. It could be assembly, it could be machine, anything. Let me know in the comments. But after this, it's ignoring. It says exception ignored, and then trace back most recent call Last. File seizures, PLM's downloads, line 6 and underscore DEL. This is line 6. Import time. Import errors. Say sys.meta path is none. Python is likely shutting down. So this is the error that it gave us. Is likely shutting down a different exception. So this is a different exception. What we were trying to get was the Python finalization error, but we got an. But what was the error that we got? It's an import error. And it's a different exception that occurs during the Python finalization process. So this error also occurs during the Python finalization process. This error is raised when the interpreter is in the process of shutting down, and certain modules or functions are no longer available. In your specific case, the import time statement inside the __del__method is causing the issue. During finalization, when Python is shutting down, the sys.meta path is set to none, which leads to the import error. To demonstrate Python exception, you can modify your code slightly to avoid the import error and simulate a different blocking operation. Okay. So we just have to modify the code a bit because what we were trying to get was the Python finalization error, right? Where is it? Yeah, this is a Python finalization error. But what we're getting is the import error. So we're going to have to modify the code a bit so that we can get the Python finalization error. So we're going to add another import time. Alright, the rest of it, is it the same? Yeah. So over here we're going to remove import time. And instead of time.sleep, we're going to add while true. And then we're going to pass. Define cleanup resources, resource. Wait a minute, define cleanup. That is after pass. Yes, it is. Cleanup resources, and then add exit.register cleanup. All right. Okay, so if we run this, so it says cleanup resources, and that is it. Well, we removed the import time statement from the __del__ method to avoid the import error. Instead of sleeping, we use an infinite loop while true pass to simulate a blocking operation. When you run this modified code and exit the script, you should see the Python finalization error being raised due to the blocking operation and custom resource set __del__ custom resource .del. This demonstrates the usage error. Well, I can see that it's not giving me any error. If I try this again, well, there's still no error. This is the output. If you're not seeing the expected Python finalization error exception even after modifying the code to simulate a blocking operation during finalization, it could be due to the specific behavior of the Python interpreter in handling finalization errors. In some cases, the interpreter may not raise exceptions for certain types of errors during finalization. To prevent potential issues with the shutdown process. However, you can still understand the concept and potential scenarios where the Python finalization error might be raised by considering the following points. Python finalization errors, including those that potentially trigger a Python finalization error, are typically related to operations that block or fail during the cleanup process when Python is shutting down. Custom scenarios, while the example provider may not always trigger the exception due to interpreter behavior, you can explore other scenarios that involve such operations that could potentially block or fail during finalization, such as complex resource cleanup, file operations, or network operations. Testing in different environments. The behavior finalization errors can vary based on Python version. Operating system interpreter settings, testing the code in different environments or with different Python versions may provide insights into how finalization errors are handled. Consulting Python documentation. Refer to the official Python documentation or release notes for Python 3.13 to understand more about the conditions under which Python finalization error is raised and the specific scenarios where it may occur. While the direct simulation of the Python finalization error exception may not always be straightforward due to interpreter behavior, exploring the concept and potential scenarios where finalization errors can occur can still enhance your understanding of Python finalization process and error handling mechanisms. So I learned a lot from this. It was pretty interesting and fun. And so until now, I learned about the Python finalization error, the Python exception, the Python history environment variable, and how it can be used to change the location of a .python history file. And we also learned about support for the PERF profiler, for better profiling, so that the frame pointers thingy, it can work without the frame pointers. Alright, so what is next? And Python finalization error exception to succession derived from them. Python finalization error. So we've done the Python finalization error. Now what is next? The following functions now raise Python finalization error instead of runtime error. Contributed by Victor Stinner and DH114570. Alright, it's already provided them. Can you use them in a code so I can see this error? So it's okay, thread.start underscore new underscore thread. Where is it? Yeah, I see it under first thread. And then there's subprocess.popen. Subprocess.popen. Where is it? Subprocess.popen. Subprocess.popen. Here it is, subprocess.popen. And then os.fork. os.fork, test fork. os.fork, where is it? It's over here, I see it. And then we have os.fork pty. os.fork pty. Fork pty, but where's os.fork pty? Yes, here it is, os.fork pty. Now we're going to try to use it in our code. So first what we want to do is import os and then import subprocess. And then import thread underscore thread. This is an underscore, right? Let me know in the comments. def child thread. I forgot the colon again for some reason. While true, we're gonna make it pass. Alright, def test fork. PID is equal to with.fork. And then there's these small brackets. If PID equals to 0, is this equal or is this an assignment? And then the colon, os.exit. And then put 0 inside the small brackets. Else, don't forget the colon. Alright, else os dot wait PID 0 test fork PTY, is that it? It's underscore. And then the colon, master, underscore FD, slave FD is equal to os dot fork PTY. If master underscore FD to 0, os dot exit, and then another 0 inside it. Okay. Else, what's gonna happen? Else, this is the parent process. Else, it's gonna os dot close. Leave underscore active. And then os dot wait PID is PID. Master FD underscore FD, comma 0. Alright. Define test open. It's test P open. And there's an underscore. Colon, okay, PROC is equal to subprocess dot P open, and then these small brackets, and then sleep. Okay, it's the quotation mark, and then the quotation marks again, quotation, and then we have PROC dot wait. And now this is the main. Start a new thread that will block during finalization. So we're going to create a new thread, and based on the answer, it's supposed to get blocked during finalization. Thread.start underscore new underscore thread child, comma, no, child underscore thread. Okay, test fork and fork PTY. Okay, it's a test underscore fork. I'm going to type it twice. Sent it. And then we have the test fork PTY. Alright, now we're going to test P open. The test underscore P open. It's a small p. Right, so if name equals main, alright. So if I try to run this, this is supposed to give me the finalization error. What is this? Else must match a valid statement here. Else, where is it? Syntax error. Wow. So might as well just copy it so I don't get the syntax error. So let's see what the code does. So first we define a child thread function. Where is it? Child thread function. Yeah, here it is. We've defined a child thread function that runs an infinite loop simulating a blocking operation. So this is a blocking operation. The test fork and test fork PTY functions. This is the test fork. And then we have the defined test fork PTY. These are two functions. These two functions create child processes using os.fork and os.fork pty respectively. So they're going to create child processes. Yes, os.fork and then store it in PID, and then os.fork pty and storing these in this. I get it. The child processes immediately exit while the parent processes wait for the child process to finish. Okay, so the child processes are going to exit first, while the parent processes are going to wait for the child process to finish. The test underscore p open function. Test underscore p open function, where is it? Yeah, here it is. Test underscore p open function creates a subprocess using subprocess.p open. Yes, I see it. To run the sleep10 command, which will block for 10 seconds. Alright, so this is going to block for 10 seconds. Okay. In the main function, we start a new thread using thread.start new thread. Yes, new thread. We do. I see it. We start a new thread. Passing the child thread function. Child thread. Where is it? Yeah, there it is. Child thread. We pass the child thread function in it. This thread will block during finalization. Okay. We call the test fork pty, and test open functions to test the specific functions mentioned in the Python 3.13 release notes. When you run this code and let it exit by pressing Ctrl+C, you should see the Python finalization error being raised for the blocked operations. And the specific error messages may vary depending on the blocked operations and the Python version you're using. This code demonstrates how the functions mentioned in the Python 3.13 release notes. Okay, so thread.start, new thread, subprocess.popen, os.fork, and os.fork pty. Can trigger the Python finalization error when operations are blocked during the finalization error. Yeah, thread.start, new thread. .popen, os.fork, os.fork pty. Okay, so let's copy the code so that the syntax error is gone. Here we go, error fixed, and then we're going to run this. Trace back. What is this? So let's read the errors. Syntax error. First, must match valid statement here. No, that's not the one. This is the one. So line 44 in module main, and then line 37 module in main test fork, and then line 10 in test fork PID is equal to os.fork. Attribute error. Module OS has no attribute fork. Well, I don't know if this is a finalization error. I don't see anywhere where it's written finalization error, you know? Python final, but this is an attribute error. Model OS has no attribute fork. Anyways, I learned a lot from this. Thank you so much, Perplexity. Thank you so much, Python. Thank you so much, the people watching the video. I hope you have all the good luck. And the people watching this video, I hope you have all the good things in life. And I wish you a long and happy life. I wish you all good health. Thank you so much for watching the video. That is it for today. I hope you learned a lot, and thank you so much once again for watching the video. I wish you happiness, good health, and a long life. Thank you so much. Take care, everyone. See you later.